My name is Mary Corey, and I am a freshwater ecologist with the Nature Conservancy's Center for Resilient Conservation Science. And in this video, I'm going to show you how to assess a river using an example from the Midwest of the United States. So let's go check out a river together. I've gotten to this part of the Resilient River Explorer by choosing Assess a River up here in the tabs. And I'm now seeing rivers in the United States. And to get to the river I want to explore, which is the Wisconsin River, I'm going to type in Wisconsin River into the box up here, the search box. And then the tool will now take me to a zoomed in part of the Wisconsin River. I click on the river line, this blue line, and a box opens up and I select this river. And now we're going to see a whole bunch of things happen. We're going to zoom out to see the whole watershed of the Wisconsin River shown by its resilience scores. And you'll see all these black dots on the map. Those are dams, and the dams create 77 different functionally connected networks within the Wisconsin River system. So each one of these functionally connected networks is the area that you could think of like a fish having to move around as it's trying to adjust to a changing climate. So the bigger the functionally connected network, the better for sure. Okay, now I think it's helpful in trying to take in the pattern of resilience to come down to the map layers and turn off these functionally connected network boundaries. And that just makes it a little easier to see. We could also turn the dams off. We want to see the whole pattern. Okay, so we can see here that there are 3 different colors. And over on our legend, that's telling us that we have some that are slightly above average, some that are average, and some that are slightly below average. We also have a little donut chart here over on the left that gives you the exact percentages for this watershed. So 62% of the watershed is average for resilience, 9% is slightly below average, and 29% is slightly above average. So there's a fair amount of resilience, and you can see how it's distributed from headwaters to the lower part. The lower part's definitely helped by having larger functionally connected networks, as you could see when we first zoomed to the Wisconsin. Okay, so now you might have a question like, okay, I can see this resilience pattern, but how does this help me focus in on where I might do conservation to improve resilience? So we were interested in that question, and so we combine this resilience information with a map of areas of biodiversity significance to create the freshwater resilient and connected network. So let's see what parts of the Wisconsin River are in the freshwater resilient and connected network. So I'm going to toggle on this map by selecting this little toggle down here. And what I first see is a simple map of resilience that's showing me those that are higher resilient, so they're areas that probably need to be protected, and then those areas that are close to being resilient that we call restore. Now we can find out more detail about what needs to be restoring by switching our view over here from the 2 class of the freshwater resilient connected network to the 5 class. You can see my legend changes. So I can see there are areas that are protect, and then 3 different categories of restore. So the brown are condition, the purple are flow, and these orange ones are areas that need to be reconnected so that they can form larger networks, and that will definitely increase the resilience. Okay, now if I want to see each one of those conservation strategies or actions by themselves, I can come over to the Opportunity tab, and now if I toggle through and select using these bolded colored text, so here under Protect, if I highlight the units, it's going to show me just the ones that fall into that Protect category. And then similarly for Reconnect, I can see just the watersheds that are close to being resilient but for being small and needing reconnection through dam removal or some modification, or the ones that need to have their flow regime restored. And those mostly occur along the main stem of the Wisconsin River. There are a number of dams that regulate the flow on the Wisconsin River. And then finally, those that need attention for their condition. So these have an issue either with water quality or a lack of natural cover in their watershed. Now, if I want to investigate more deeply what's going on in any one of these watersheds, then I could switch over to the Explore the Data tab, and we have a series of videos that explains how that tab works. And that will actually let you see exactly what's driving these different resilience scores for a given location. So assess a river is a great way to see what's happening in an entire watershed. And you can do this for any river just by zooming in and selecting that river line, like for the Jump River here. I can select that, and now my view is gonna change just to show me the resilience for the Jump River and its related functionally connected networks. Okay, thank you, and enjoy assessing your river.